Welcome. Today, we're diving into operations on rational algebraic expressions. This is a key topic in 8th grade math, where we learn how to work with expressions that involve fractions and variables. We'll explore how to add, subtract, multiply, and divide these expressions, building skills that are essential for higher-level math. Let's get started. In this section, we're focusing on 4 key skills. First, performing the 4 operations: addition, subtraction, multiplication, and division. Then, simplifying the results so they're clear and easy to understand. We'll also learn how to state variable restrictions, which keep our solutions valid. Finally, we'll apply all of this by solving practice problems. These objectives guide us through mastering the essential steps in working with expressions. Let's talk about sharing pizza, a simple way to understand division and fractions. If X students share 2 pizzas equally, each one gets 2 divided by X, or 2 over. Now, imagine we add a little more, another 3 over X pizza. What happens then? This question sets the stage for exploring how adding fractions works and why it matters. It's a tasty way to motivate the math behind it all. Let's take a moment to recall what a rational algebraic expression really is. It's a fraction where both the top and bottom are polynomials. We call the top the numerator, and the bottom the denominator. But there's a crucial rule: the denominator can never be 0. So part of working with these expressions is identifying any restrictions, values of that would make the denominator 0, and therefore not allowed. This quick review sets us up for what's coming next. When we multiply fractions, there are 3 key steps to follow. First, factor any numbers or expressions where possible. Next, multiply the numerators together, and then the denominators together. Finally, look for any common factors that can be cancelled out to simplify the result. For example, multiplying 3x over 4 by 8 over 9x gives us 2/3 after cancelling. This process keeps multiplication straightforward and the answers neat. Now, let's work through this problem together. We're multiplying 2 fractions that both contain the variable. The key here is to simplify step by step. First, we'll multiply the numerators and then the denominators. Then, we'll look for common factors to reduce the expression. This guided practice will help us see how to handle variables in fractions with confidence. Let's dive in and solve it side by side. Let's break down this example using the keep, change, flip method for division. We start with the expression over 6 divided by 2 over. When dividing fractions, we keep the first fraction as is. Then, we change the division sign to multiplication. Finally, we flip the second fraction, swapping its numerator and denominator. That turns the problem into x over 6 multiplied by x over 2. Multiplying straight across, we get x squared over 12. It's a simple but powerful approach. Let's work through this problem together. We're asked to divide over 4 by 3 over. When dividing fractions, we flip the second fraction and multiply. So, x over 4 times x over 3. From there, we multiply the numerators and the denominators. This guided practice helps us get comfortable with dividing fractions that include variables. It's a key skill for solving more complex algebra problems. When we add or subtract fractions, the first step is to find the LCD, the least common denominator. This is the smallest number that both denominators share. For example, if we have fractions with x and 2x in the denominator, the LCD is 2x. Once we find the LCD, we rewrite each fraction to have that denominator, then add or subtract the numerators. This keeps everything consistent and makes the operation straightforward. Let's see how this works with these examples. Now we're diving into a pair activity focused on solving 2 expressions. The first is 5 divided by x minus 2/3. The second is x divided by 5 plus 1/2. Work together to find your solutions, then explain how you arrived at them. This is a chance to practice, compare methods, and deepen your understanding by talking through the steps with a partner. Let's get started. Now let's turn to some independent practice. Here, we're working with fractions and variables, simplifying expressions, dividing, adding, and subtracting terms within the denominator. These problems help us get comfortable with the rules and build confidence. Take your time, and remember to look for common denominators and simplify wherever you can. This practice is key to mastering the concepts we've covered so far. Let's wrap up by reviewing a few key points. First, we need to state one rule for multiplying RAEs. Then, we'll consider why the LCD, the least common denominator, is necessary. Finally, we'll look at the restriction that applies to the expression 4 over. These questions will help us check our understanding before we finish. This video was created with SlideSpeak. Visit SlideSpeak to turn your presentations into engaging AI-narrated videos.